We thought this evening we would do a question and answer session. So now is your chance to ask us any questions. Well, not about anything, obviously, but astronomy or space related. We
may not answer anything.
Careful.
Yeah. So if you have any questions, now is your chance. Put them in the live chat, and we are awaiting your questions eagerly here. Don't all rush at once.
Yeah, we've got we've already got a couple that have already been put in. I think some people have been answering as we've gone along. Now I think it's Anthony Page. I could be wrong on that. If I've got that wrong, I do apologise. It says, "Will the supernova in M101 will it turn into a supernova?"
Black hole.
A black hole, sorry.
It won't turn into another one.
I think it's a supernova.
You never know. Might be a repeater.
Yeah. Well,
you only need 5 to 10 solar masses to get black hole status, right?
Yes. So we don't really know the mass of the progenitor star. So if the star was massive enough, it will have collapsed into a black hole. If it wasn't quite that massive, it will form a neutron star, but it will either turn into a black hole or a neutron star. So as far as our theories have it, so one of the two. So we don't know. These things are often very difficult to ascertain. For example, with supernova 1987A, and 1987 is a hell of a long time ago now. Astronomers expected it to collapse into a neutron star, and it's only very recently, after all these years, that they think they have found evidence of a hot spot right at the center of the supernova remnant, which represents a neutron star in X-rays. And it's shielded from us by enormous clouds of dust. So this is why it's taken so long to find it, because the dust has taken since 1987 to clear to a point where we can start observing it. So we may not know about this supernova in M101 for quite a while, what happened. So there we are. Okay, there's a question here, which I'll put up on the screen. Lee says, would you rather travel to the moon and be able to return, or travel to another planet, exoplanet, or moon and never return? Panel.
Ooh.
Do you have to go alone, or can you take people with you?
That's it. Make it technical, Rachel.
Yeah.
I don't know.
Because I don't want to have to take Johnny if I can't.
Oh. Being recorded.
I have to
go to a planet with if they had Wi-Fi. If the planet had Wi-Fi, I might go.
Yeah. You'd have to set it up.
Yeah. To be honest, I think the moon's been done.
Not by me.
And no, I know, but you know what I mean. We've been there. We've seen it close up. I think I would like to travel to some of the outer solar system planets and have a look at myself at some of these extraordinary moons that we've got out there. And I could still come back. Well, no, I can't now because I'm getting on a bit. So yeah, wherever I go, there's a good chance I'm not going to come back. So it doesn't really matter.
I've got it for you. When you step off the spacecraft onto the new world, it's one small step for Daz.
Yeah.
The last step for Daz. The last step for Daz.
I'd like to say something about that. I think the moon will attract a lot of tourists when the time comes. Even though you say it's been done, I think it'll be a good place for tourists to go to when the opportunity's there.
Personally speaking,
a
stab at the moon for me, but I wouldn't mind a good look around Bristol. I've already driven through it.
But when you talk about the moon, it's going to become one industrial complex. I can see it happening, and there'll be mining for everything that they can find. But the thing is, before anyone can mine anything, how are they going to sort out because the moon's owned by no one. How are they going to sort out rights? You can't just go and knock a stake into the ground, and that's where you're going to dig. So
you got to
it's
Federation of Planets.
Yeah, well, yeah, or it'll be something like out of the Expanse, where you got the outers, the inners and the outers. But no, it's strange. It's a strange. It's a strange. I think we'd like to go anywhere. To be quite honest, I don't think anyone would turn down a trip anywhere. Yeah, I don't know. Somebody else. Anyone else got any ideas?
Well, I think I would go to the moon and come back again, because I can't imagine not wanting to come back, to be quite honest. My daughter would never forgive me. So
I think I would like to go to Mars.
Yeah, we'd like you to as well.
If only for the photographic possibilities there.
Yeah.
I think I'd go to the moon and come back.
Yeah.
And if you think about all the planets we image and how gorgeous they are, actually ours is probably one of the prettiest. We don't realise how nice we are if we were actually on another planet looking at ours. I think we're one of the most pretty planets to look at. So I think anybody else would be desperate to get to these blue pools of water and all this stuff. I think we probably don't realise how lucky we are.
When will the first human use a telescope on another world to view the Earth?
It's already been done.
No, the first human now.
Oh, right.
Yes. I don't mean like robot.
All right.
Well, it would be the moon. I think there are no other options if you're looking for firsts.
It will be on the moon, wouldn't it? Yeah.
Yeah, definitely. All right. So thank you very much for that question. Very interesting, thought-provoking question. And we have another one here. Somebody asking about the long-term future of the solar system. So let me just find here we are. Just put this up. My software appears to just be grinding to a halt for some reason. We've really got problems tonight. But there we are. Here's the question. What is the long-term story for the solar system? After the sun goes to a white, brown, or brown dwarf, the planets are just left hanging about. Is there any way our system reverts to a cloud of gas or dust and starts again? Who wants to take that one?
Well, we won't go to brown dwarf, because brown dwarf's a failed star. They'll go to a white dwarf. But before that happens, of course, as we know, it's going to go through the giant stage, where it's going to expand as it stops burning hydrogen. It'll start to try to burn helium, which needs more energy, which means the outer layers will expand. And of course, as we all know, it will probably engulf all the way out to Mercury, Venus, and possibly even the Earth. But even if it doesn't devour the Earth, it will blow off the atmosphere. So the Earth will become a sterile planet anyway. It'll also go through a pulsating stage. So it'll sort of like throb for a while. Now, whether or not we would be able to, basically, we don't want to be around when that happens anyway. But what whether or not that means that because the planet is expanding, we've had this discussion before at some time, whether or not the Goldilocks zone where life can actually exist will move outward out to the outer planets of the solar system. I mean, you will get some of these ices melting on these moons because the sun will be throwing out far more radiation. But whether or not it means that we could move out just to the outer planets is debatable. because you know at the end of the day that once we get to, I mean, we're talking about billions of years off anyway, so we won't be around to see it anyway. But that's what's going to happen. But whether or not really we want to be outside the solar system and hopefully doing interstellar travel, if we're going to survive. So sorry to be a bit negative on that, but anybody else got any thoughts?
I think the thing is that according to what we think about the long-term future of the sun, when it does swell up into firstly, in about 1 billion years, increasing solar radiation will make the Earth uninhabitable. It will sterilize the Earth. So although the planet has got maybe 4 or 5 billion years left before the sun either swallows it or gets impossibly close to it, that it just burns to a cinder, in about 1 billion years, increasing solar radiation will sterilize all life on this planet. And we think that the sun will indeed swallow Mercury, Venus, and the Earth. The planets beyond that will be okay. So we think. So the solar system will carry on pretty much in its current form, but without Venus, the Earth, and Mercury. So that is really the long-term future of the solar system. I don't think there's any sort of chance that it will repeat. But, the sun will be in its red giant phase for millions of years, and then it will very, very slowly shrink down to a white dwarf and eventually cool altogether into what's called a black dwarf, which is a sort of the cinder left from the white dwarf. But that's all very, very far in the future after the red giant phase.
One of the interesting impacts of having a red giant star is that you have reduced ultraviolet radiation. You have reduced high energy radiation. Yeah. And so there have actually been attempts to model this kind of thing for the outer solar system, right? And there's a paper by Chris McKay and others. Chris, I think, is out at Ames Research Center, and imagining what it would be like to live on Titan under a red giant sun. And with the reduced ultraviolet emission from the sun, the atmosphere of Titan would clear up, right? Because you would be dampening down the photochemistry that's causing the haze. And it would be warmer because you've got this huge sun that's pumping out lots of photons with this huge surface area. And so it might be a nice place to live, either moons of Saturn or Uranus.
Yeah, as I said, the Goldilocks zone could move out. The only other thing is when, like you were saying, Andy, it will eventually be a white dwarf and then a black dwarf. Would there be enough mass in the white dwarf or the black dwarf to actually keep the planets in their orbits?
You could probably do the calculations, but don't forget.
No, I'm not going to.
The answer is yes, there should be, but the planets will move further out in their orbits because there will be reduced mass because of the ejection of the outer envelope of the sun.
Yeah, absolutely. Okay. Absolutely. Yep.
Interesting.
Okay, thank you for that question. Bernard, could you do me a favor and take over the posting of the questions on the screen, because my software here is just about ground to a halt. If you could do that.
Yeah, which question do we want to?
Well, the one after that one, basically, the one after Graham's question.
Oh, okay.
I think it was actually. I think I've just found it. Oh God, it's gone again. I do apologise, viewers. We're having real technical problems for some reason tonight.
Is it the one from Steve? Talk about the white dwarf or something?
No, it's before that.
Sorry about that, Steve.
Okay, just give me 1 second. I have it here.
I'm just
right. I've got it. It's the one from Chris, and Chris wants to know, which I've just. No, not that one. Okay, here it is. Sorry, Chris, I'm having a few problems here. Okay, Chris says, do the panel think extraterrestrial life will be discovered in some form in the next 15 years?
I wouldn't like to put an ultimate time frame on it, but I would have said that it's inevitable at some point that it's going to happen, but whether or not it's within 15. But at some point, it will give. It's the way it is now. Statistically, it has to happen at some point, which is why what I was saying earlier is to not rule out everything completely, because what we perceive at the moment might not necessarily be in a state that we can actually see, hear, or be observant of. So it might in actuality be already in a state of what we're unfamiliar or unable to recognize. But time frame wise, it will happen. It's inevitable, I'm sure of it.
Yeah, I think in 15 years we'll probably know whether or not we'll have a better idea whether or not it exists in our solar system. But as you said, Jonathan, that we may be missing something as well. So it's not a guarantee. We hopefully will have some results back from the probes that are on their way out to the Clipper and Juice, which will give us some idea of what's happening at these places. But I don't think if we find it, all well and good. But I think it's better to say that we'll have a better idea of whether or not it exists in our solar system. But you can't tell about anywhere else.
Yeah, I think Mars sample return. I'm putting all my money on Mars sample return in 4 years.
You're putting the house on it.
Microbial life in the soil of Mars.
That'd be fascinating.
Ways to get beyond the radiation and the perchlorates, but that's what I think.
And in case viewers you're not sure what that's all about, these are the samples of Martian rock and soil that the Perseverance rover has been taking and packing in special tubes, which it is leaving on the surface of Mars to be picked up by a space mission in about 10 years, they say, isn't it, Lou, I think?
I thought it was, earlier than that. I was going to say 2 more, 4 years, 4 or 6 years. I don't think it's 10.
I think it's been pushed to sort of like almost the mid 30s now.
I'm sure it was 10.
But I think. Well, I mean, we're dissing. We're missing out. Bennu might bring us a surprise.
Yeah.
When the Osiris Rex brings the thing, you never know. So
in an infinite universe, anything is possible. After all.
Mm-hmm.
Okay. Any other thoughts on that? No. Okay.
Nope.
Well, personally, I think we will definitely find signs of life in our solar system. I'm not sure about 15 years, maybe 20 or 30 years, because we need to start sending more missions to the outer planets, which is where all the fun is, apart from Mars, obviously. But my money would be on Enceladus or Europa at the moment, possibly Titan, but we don't know. We will know more when Juice and the Europa Clipper get there to see whether the environments are indeed conducive to what we conceive of as life. But I think it'll be a few decades before we can conclusively prove life elsewhere in the solar system, unless, of course, the Mars sample return indicates otherwise before that.
I'm surprised no one's mentioned UFOs.
No, I'm not.
How far away can we get from that?
You mean UAPs?
Okay.
Yes, UAPs indeed.
UAP. Yes, I don't know what happened to UFO. There we are.
The new definition.
Unidentified aerial phenomena. Da 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 da. Phenomena. Da 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 da.
That's anomalous phenomenon.
Yeah. Oh, is it anomalous?
Unidentified anomalous phenomenon. Yeah.
Okay, let's move on. Thank you for that. Another question from Chris now. We're going in strict order here to be fair to everybody. If the universe is constantly expanding in all directions, on what scale is it expanding? The space between atoms, am I getting bigger? Well, some of us are. And any thoughts about that?
Are you getting bigger?
If space is expanding, no.
Yeah, no. It's unless you're producing dark energy to generate your expansion, then I shouldn't think so.
I think this idea of space expanding is a little bit of a misnomer, a little bit misleading, because as I understand it, and please correct me if I'm wrong, which I'm sure you will, as I understand it, it doesn't literally mean that things are expanding. It means the volume of the universe occupied by matter is getting bigger. And I think that's what it's talking about. It's not really talking about things expanding and getting bigger. It's just that since the Big Bang, the volume of space occupied by matter is getting bigger, and that's all it is, really, I think. So things are flying apart in all directions. It's like blowing up a balloon. The volume of the balloon gets bigger as you blow it up, but it doesn't mean that anything inside the balloon is literally getting bigger. So I don't think you have to worry, because you're not going to pop, as it were.
Yeah, well, just talking about that, when you asked about the T-shirts, I think we've certainly got a problem with expansion in our viewers with the sizes that they were putting in there.
I did see that.
And
somebody wanted a 3X.
I did. I include myself in that.
Yeah, Jonathan.
Go ahead.
No, I was just pointing out my expansion rate as well.
So isn't that proof that dark matter exists then? Those T-shirts getting bigger and bigger.
Yeah. Lou, have you got any thoughts on that?
I was just going to say that yes, you're right. It's space that's expanding, not the objects in space. But the result of this is that the bulk density of matter in the universe is getting less and less.
Yeah, of course.
And so at some point, trillions of years in the future, if you just extrapolate this outward, things won't be close enough together to form anything new. So we won't be able to form any stars or planets. And other stars will have died out as they've slowly given off the last radiation they had, and so it'll be a pretty dark universe.
Yeah. So, like, going on from that, and I'm just picking out another question here. It's actually from my daughter, which actually follows on the same line in a way. It said it is believed that there is an ending point of the universe. And if there is, what do we believe lays beyond? Well, you're going to be disappointed with the answer. We don't know.
I was going to say something similar, I think.
Yeah, it's. I mean, when we can only view in any one direction. I think it's 46 billion light years either way. So if you take that and we look the other way, you're talking about 92, 93 billion light years. That's all we can see. That is the observable universe that we can see at this moment. And that's in all directions, no matter which way you point your telescope. If you're in the southern hemisphere, the northern hemisphere, it's the same. That's all we can see. Now, if somebody was 46 billion light years and 1 meter beyond that, they wouldn't be able to see us, as we cannot see them, because they are just outside our range. But it also means that if you're anywhere in the universe and you look out, you will see exactly the same. So, and the reason we can only see that far is it's because it takes time for the light from these objects to reach us. And as we were talking about with expansion, and also as things get farther away, they increase their speed. And eventually they will possibly get to a speed where they will go almost as fast as the speed of light, so that we will never catch up with that light. So there's a chance that we will never know. But as regards if there is an edge, we don't know where it is, if it does exist, and what's beyond it we do not know. But of course there is also the theory of multiverses, so there could be more universes in their own bubbles in different just outside there. But unfortunately, we cannot tell you what lies beyond, I'm afraid.
Talking of which, what I was going to say was, if space is expanding, my question has always been, which I can't get my head around, is it expanding into anything? And what is it expanding into?
I think that the quick answer is no, because there's nothing by definition, there's nothing beyond it, so it cannot be expanding into anything. I'll leave you to ponder that one. On a similar note, by the way, can I just say hello to Mark Thompson? Hello, Mark. How are you? Nice to see you. Thank you for dropping in. Hope you're okay. Hope everything's okay. Lovely to see you. Haven't seen you in a while. And we're bidding good night at this point to Kevin and to Rachel, both of which have retired for the evening. So thanks, guys, for being with us, and we'll catch you next week. On a similar note, John Walton wants to know, do you believe the theory that the universe will retract once it can't expand anymore?
No. Like a rubber band.
I can't see it, because if it's expanding and the expansion speeding up, eventually everything will be so far apart that the gravity will be so weak that it can't retract. Also, I think Ian's put here that the universe will suffer heat death, which is, again, that goes on to something else. That's about the use of hydrogen and things like that.
Sure.
And when we run out of hydrogen and the stars finally start dying and there's no more hydrogen to ignite more stars. But I cannot see that a retraction, or as they call it, the bounce, whether or not it would actually, that'll happen. I can't see it happening. From what we understand.
So it depends directly, John, on the amount of matter in the universe. In other words, how much gravitational attraction there is. And I think successive surveys, having come up with an estimated amount of matter in the universe, has indicated there's simply not enough matter in the universe for gravity to arrest and then reverse the expansion of the universe. And I can't give you any exact figures because I can't remember them, but I'm sure I've read at least 2 surveys that have said, no, there's not enough matter in the universe for the universe to slow down and then contract again. And then, of course, on top of that, as Daz said, we have the additional problem, in inverted commas, of dark energy, which is actually expanding accelerating the expansion of the universe. So it looks even more unlikely now. We don't know what dark energy.
Our standard candles, and
absolutely. We don't know what dark energy will do in the future, though, because we have little idea what it is at the moment. We do seem to know, I believe, that dark energy didn't start making its presence felt until about 6 billion years after the Big Bang, in which there was some sort of what they call a phase transition. Something happened in the universe where dark energy got the upper hand over the arresting power of gravity, if you like. So there we are.
Gerard says dark matter does exist and it's responsible for the rapid expansion, and it's called Guinness.
Yeah. Oh, don't mention that. I'm going to Ireland in November to speak at the County Mayo Star Party, and I just can't wait to get back and have some proper Guinness, because the Guinness in Ireland, as you probably know, is just nothing like what is found on mainland UK. It's a completely different drink, and it's quite wonderful. Anyway, so there we are. Do we have any other questions? I don't think we have any further questions. Any other questions out there? Any that I've missed? If so, please ask them again. I think that was it.
There was one that was solicited from a friend of Amber's. In fact, it's Ollie. He and his brother won the binoculars. It's a neighbour, and he was talking about how long does it take the light from the moon to reach us, and really we're talking about the speed of light here, and as we know, the speed of light is approximately 300 million kilometers per second, or that's 677 million miles per hour. Well, as we know, the sun emits its light, and it takes 8 minutes and 20 seconds about to reach us. And for it to reach the moon, you would have to add another 1 at 1 minute 20 seconds, because it's 1 1.33 seconds that the light takes for it to come back to us when it's reflected. And of course, because it's all to do with the light is reflected, because we know the moon doesn't emit light like the sun. It's reflected light, and it's a thing called its albedo, and it's usually the makeup of the planet or the moon. What it's made up of will determine how much light is reflected. But the speed of light will always be constant. And just to add a little bit to it, light from Jupiter takes 35 to 52 minutes to reach us here. Pluto takes 5.5 hours. The variation of the Jupiter is because of the orbits, the shapes of the orbits and things like that. Pluto takes 5.5 hours on average. The nearest star, Alpha Centauri, takes 4 years. What have I got here? 4 years. 4.3 years. Sorry. That's Alpha Centauri. The brightest star is 9 years. That's Sirius. Betelgeuse or Betelgeuse is 430 years. It takes the light from there to come to us. Orion Nebula is 1,500 years, and the Andromeda Galaxy takes 2.5 million years. And of course, when we're talking again, I'll reiterate it, that's with light traveling at 677 million miles per hour. And that's how long these lights are traveling towards us.
How long does it take for the light from your to-do list to reach your eyes?
Weeks.
On a week. 7 days.
Years.
Yeah. Great. Well, thank you.
Yeah. Well, that's it. The to-do list that. I'll always get round to it, but they don't have to tell me every 6 months.
We've got another question here from Elaine. Moving on. If there are multiverses, would our expanding universe expand into another universe? And what would happen to matter if the laws of physics in the other universe are different to ours? Now, that's a good question.
Wow.
Yeah, because I think we've discussed this before, Andy. In the microwave background, and this was hypothesized a few years back, they believe they found around bruises in the microwave background, which they think could be where multiverses, other bubble verses, have bumped into us. Now, whether or not this is correct, nobody really knows. But they said that by looking at the microwave background, they think they've detected these round bruising, as they call it, which could be multiverses bumping into us. I don't know, because that means they're talking about that we're like a bubble. And it's sort of like our membranes bumping together and things like that.
Do you want to
I don't know.
About that, Daz? This is really angels on the head of a pin stuff. Because we can never know, because presumably Elaine's quite right that any other universe is almost certainly going to have laws of physics different to ours. If physics exists in other universes, we have no way of even contemplating what other universes could be and what they could look like. We can only detect things that are within our own universe, and probably will never be able to detect anything beyond that. Although, of course, I never say never, but it's highly unlikely that we would ever be able to have any direct observations of those other universes if they exist. If they collided, God, I don't know.
There is some question as to why the force of gravity in our universe is so weak, or at least relatively so weak to the other three.
That's right. It's meant to be leaking, isn't it?
And so it would be consistent, or one. There's no way. I don't know how you test this, but one thing that's been advanced is that perhaps it's leaking out
puncture.
Yeah, very, very, very slow puncture. Yeah. These things are really beyond us to be able to give you any real answer, Elaine. I'm afraid it's it's a lot of this becomes quite philosophical, really. However,
it's like you say, gravity for what it is weak, but it's very, very influential.
Well, you see, if you believe, although believe is not the right word with science, of course, if you acknowledge the idea of what's called perpetual cosmic inflation, that makes other universes inevitable, in fact. That we have these sort of baby universes that sort of bud off, and there could be an infinite number of them out there. But we don't know. We don't know, and so that's the honest answer. Possibly, possibly not. If two of those universes do collide, who knows what would happen? I think it's beyond us to really come up with any sort of meaningful answer to that at the moment, unfortunately, Elaine. But watch this space. You never know. You never know.
I mean, it could be a case of that everything in these universes is obliterated as if both bubbles pop, and you get another expansion, and it could start all over again.
Absolutely.
I hope if there is there is another universe, I am really hoping that it has affordable electric cars.
A distinct lack of road work
in our universe.
Yeah, roads without potholes. Yeah,
and Indian restaurants on every corner. Okay, right then. So, unless there are any more questions, we will draw that Q&A session to a close, and we'll move straight on